Welcome to the IM2 review sheet solution. This is for chapter 7. Here we have the last page, page 4. We are going to go over 11, 12, 13, 14, and 15, which all deal with the trig part. Here it says an air traffic controller is on top of a 115 feet high tower and is looking with an angle of depression of 12 degrees. How far is the pilot away from the base of the tower? The base of the tower, how far the base of the tower would be is right here. This would be the base of the tower. The base of the tower would be this length. So we set up the triangle. The triangle should look something like this. If you don't believe me, I can write this for you. Right. Nope, not quite. So let me flip this again. Right, perfect. Do you see how it matches there? Like that. So I can now label it. This is my 12 degree, which is right here. 12 degree. We saw this as my 150 feet. Okay, and you don't know the base of the tower, so I'm going to have X. That was the base of the tower. Okay, so now let's approach this. So we draw our guy. We saw 12 is our theta. We know 150 is our opposite. And we know X is our adjacent. We write the letters O and A. Now we pull up our notes to see which one is O and A. We saw that that is TOA. So that's TOA. So we write TOA here. This allows us to set up the trig ratio. We can write tan 12 is going to be equal to our opposite, which is 150, divided by our adjacent, which is X. Our goal is trying to get X alone, so we can cross multiply. So you're going to multiply by X to both sides. You get X tan of 12 is equal to 150. Now you're going to divide this by 12, tan 12 to both sides, because that's how we get rid of it. Why? Because tan 12 divided by tan 12 just becomes 1. That's why. So what do you have left over on the left hand side, which is just X, is equal to 150 divided by tan 12. So let's pull up decimals. I type in 150 divided by tan 12. I get 105.69. I can round that out to 705.7. 705.7. And here we use the units of feet, so I just want to make sure I write 705.7 feet. And the fact that we round, we use the approximate symbol. It's approximately 705.7. Let's look at 12. A student is looking outside a bus that is 97 feet away from the Eiffel Tower with an angle of elevation of 27 degrees. What is the height of the Eiffel Tower in this situation? Round your answer to the nearest tenth. Let's make sure we can draw a triangle for this situation. Does it look like that? I could make it a little bit smaller. Yep, looks like this. Perfect. Some things that we have is we have the 27 degrees here is the angle here. We have the 97, which is how far the bus is, and we need to know the height of the Eiffel Tower, which is going to be right here. This is the height. So this is also going to be the height. I do not know what letter to use, so I'm going to use the letter H for height. Now we can solve this like a trig problem. We draw the guy. From the point of view of the 27 degrees, 97 is going to be our adjacent, and H is going to be our opposite. So we have the letters O and A. We bring up our notes. O and A is TOA, so we are going to use tan. So I write tan of 27 is equal to opposite, which is H, over adjacent, which is 97. I'm trying to get H alone, so I'm going to multiply by 97 to both sides. I get 97 times tan 27 degrees. That's going to be equal to H. Now I can plug this into the calculator. (97) times tan 27. So I get 49.4. So I can roughly round that to 94.4. So height is not 49.4, and I rounded, so I use the approximate symbol. So there you go. 49.4 is the approximate height in this situation, and I use the units of feet. Okay. The top of the slide is 12 feet from the ground and has an angle of depression of 53. What is the length of the slide? Round your answer to the nearest tenth. Let's start by drawing a right triangle. Let's rotate this so you can match it. Okay, so it looks like that. Good. We saw that the angle here is the 53 degrees. The 12 feet is the top of the slide, so 12 feet is the top is how high it is, and we are trying to find the length of the slide. So this is the slide in of itself, and we do not know what it is, so we are going to use the letter S for slide. So now we can set up our trig ratio. We draw the guy here. We saw 12 feet is our opposite because that is our farthest away, and our side is our longest side. So this is going to be our hypotenuse. So I have O and H. I look at my notes for O and H, which is sine. I can write sine of 53 degrees is equal to opposite, which is 12, divided by H, which is S. I'm trying to get S alone, so I'm going to multiply both sides by S. Please understand S over S, right? S over S is just 1, so this cancels out. So what I have left over here is a 12 on the right hand side, and I have an S times sine of 53 degrees. Okay, now I need to know S. I have to keep S alone, so I have to divide by sine 53. Divide by sine of 53. I get S is equal to, I can now plug that into decimals. 12 divided by sine of 53. I get 15.02. So I can say it is roughly 15.02, so 15.0. And I use the approximate symbol here, and the units we have here is feet, so 15 feet. Oh, that is one tall slide. Let's look at 14. This is one long slide. You wouldn't want to go on it. You would fall. 14. I'm just laughing. I'm just laughing. Hold on, this is funny because I made this question. Oh my god, this is hilarious. The slide is 12 feet tall. Oh my god. Oh man. And the slide goes down at 15 feet. That's not safe. Oh my god, that's funny. Okay. Oh wow, that was just so funny. 12 feet slide. Oh man, I gotta make the numbers more reasonable. Okay, it's funny. It's funny. Only a math person would get the joke. Okay. I was just laughing. I cried how funny that was. Okay. 14. So the top of a signal tower is 120 meters above sea level. The angle of elevation from the ship to the top of the tower is 25 feet. How far is the ship away from the base of the tower? Round your answer to the nearest tenth. When they're looking for the tower is 12 meters above the sea, so we can say that's the height. The how far the ship away is from the base of the tower is how far is the ship. Far is the ship would be this length here. So we set up the triangle. Looks something like this. The tower is 120 feet. The angle here is 25 degrees. We do not know how far that is, so I'm going to use the letter L for length. Now we could label it. We draw the guy here. The length is our adjacent because that is our closest one. The 120 is the height, or in this case, it's going to be our opposite because it's our farthest one. Now I have A, I have O and A, so I bring up my notes. Which one has O and A in it? Which is TOA, T-O-A. Now I can set up my trig ratio. I can write tan of 25 degrees is going to be equal to opposite, which is 120, divided by adjacent, which is L. I'm trying to get L alone, so I'm going to multiply by L to both sides. Please understand why, because what's L over L? That becomes 1. That is the reason why I multiply by L to both sides. I get L times tan of 25 is equal to 120. Now I'm going to divide by tan 25 to both sides, because again I'm trying to get the L by itself. So I had L is equal to 120 divided by tan of 25, parentheses of course. I put this up in decimals. 120 divided by tan of 25, that gets me to 57.3. So I can say it's approximately 200 and 200. So I can say that L is approximately 257.3 meters away. That is how far the ship is away. 15. You're standing at on a footbridge that is 12 feet above a lake. You look down and see a duck in the water. The duck is 7 feet away from the footbridge. What is the angle of elevation from the duck to you? Round to your nearest answer. So we draw the triangle. It should look like that. The box just shows it's a right triangle. The person was at 12 feet high and the duck was 7 feet away. We're looking for the angle of elevation. So from the duck's point of view, the duck was right here. So the theta is right here. Remember, we are looking up. It's the angle of elevation. You are looking up. So the theta is from this point of view. You draw the guy. 7 is going to be your adjacent. Your 12 is your opposite. So tan. Oh, sorry. I'm skipping steps here. I have the O and A are my two letters. So I look at my notes and I see O and A, which is TOA, T. So I write T here. TOA. So I can now set up my trig ratio. I can write tan of theta is equal to opposite, which is 12, divided by your adjacent, which is your 7. I'm trying to get my theta alone. So remember, you're going right here, you're trying, here's the note, right? You're going to try to solve for an angle. And when you solve for the angle, understand that you are solving, when you use the regular trig ratio when you solve for a missing side, but if you want an angle, you have to use the inverse trig ratio. So we need theta, so we use the inverse trig ratio. So theta is equal to tan inverse of 12 over 7. Now you can plug this into Desmos. So the inverse symbols are, if you hit function FUNC, tan inverse 12 divided by 7, it gets you 59.74. You can roughly say that it's 59.8, so theta is 59.8 degrees. That is the angle of elevation from the duck's point of view. Okay, and there you go. Those are all your solutions for the review sheet.